Hi everybody, I'm back again for your next lesson on factoring. So far you've learned two types of factoring methods, okay? So I'm just going to talk about this. So far our factoring methods include 1, the difference of two perfect squares, and 2, greatest common factor. You should always look for the greatest common factor first, and if you notice in the do now, there is a greatest common factor between 10 and 25 of 5. And when you look at x cubed and x, the smaller one would be x. They both have an x in common. So I am going to take that GCF and I'm going to divide each term by the GCF, and that would leave me with 2x to the second plus 5. The x's divide out, so this is my answer. 5x times 2x squared plus 5. In the second one, the greatest common factor between 3 and 18 is 3, and between x and x squared should be 3x. So divide each term by 3x, and you have x minus 6, and there's your answer. In this last one, they have a common factor. This is your common factor. 2x plus 1. That comes down. Your other two pieces, which here are 5x and positive 4, make up your other factor. Okay? So today we are going to learn how to factor by grouping. Factor by grouping is going to look very similar to that last example we just did. But if you notice, I have your steps on the side. You're going to factor using GCF for the first two terms. So you're going to factor these first two terms together. I like to say I'm going to group them together. And then you're going to factor the second two terms by GCF and group them together. So watch, if I look at the first two terms, there's no GCF between the 2 and the 3, and when I look at x cubed and x squared is the GCF. If I divide each of these by x squared, literally if you want to show it, you can divide each by x squared. You get a 2x minus 3. Okay, the x squareds divide out. Now, very important, this sign in the middle. See this sign in the middle? Since it is a negative, you are going to pull out a negative GCF. If that sign was a positive, you will pull out a positive GCF. So whatever that sign is in the middle, it comes down. The GCF between 4 and 6 will be 2, and there's no x in common, so that's your GCF. Now, if you divide each of these by negative 2, you'll get positive 2x and a minus 3. And now, what do you notice? Look at your two sets of parentheses, 2x minus 3 and 2x minus 3. They match, and it looks just like this example from the do now. That means that 2x minus 3 is one of your factors. Can anybody name the other factor? Well, hopefully you all said, let's see what color I want, x squared minus 2. That is your other factor. So we found the GCF of the first two terms, the GCF of the second two terms. If you're doing it correctly, that means your two pieces in parentheses must match. I'll write a note. Inside parentheses must match. If they don't match, you did it wrong. It's a great way to tell whether you're doing it correct. When they match, it comes down as one of your factors, and your other two pieces work together to build your other factor. So I'll jump around and do a few, but let's just take a look at this first example. I'm grouping these first two and these second two together. The GCF of the first two is y squared, and I would have y plus 1 left over. Since this term here is a plus, that's what comes down. That sign is really important. So since that is a plus, I bring down a plus, and the GCF between 7y and 7 is 7. If I divide each of these by 7, I get y plus 1. So again, I divided these two by y squared, and I divided these two by 7. Notice they match. Y plus 1, there's one of your factors. Your other factor, y squared plus 7. The two GCFs in the front form your other factor. Okay, I'm going to try another. I'm going to go straight down to the a cubed. Okay, so if I group these two together and these two together, the GCF of the first two is a squared, and I would have an a minus 3 left over. I want you to immediately take notice. This is a negative sign. That has to be brought down. The GCF between 2a or negative 2a and 6 is going to be a negative 2. And if you divide each of these by negative 2, I get a, positive a, because a negative divided by a negative is a positive, and then a minus 3. So I divided these two by the GCF of a squared and the other two by my GCF of negative 2. Now again, the order of this doesn't matter, but you notice these match. So you know one of your factors is a minus 3. Your other factor is a squared minus 2. Your other two GCFs. This guy with this guy. That's why it's very important for you to bring the sign down in front of your second two terms. Okay. Let's try another. Let's say, which one do we want to do? How about, I don't know, should I just go right down the row? I will. I'll do this one. I'm going to find the GCF of these two and these two. My GCF of the first two happens to be p squared. 2 and 5 have no greatest common factor, so I'm going to pull out a p squared. If I divide each of these by just p squared, I divide my coefficients to get 2, subtract my exponents to get a p, minus 5, because the p squareds are gone. Remember, this is important. If that's a negative, I need to bring down a negative. The GCF between 4 and 10 should be 2. When I now divide this term and this term by negative 2, I get a positive 2p and a minus 5, because 10 divided by negative 2 is negative 5. I know I'm right. These two, match. Match, match. It can come down first or second. The order doesn't matter. As long as one of your factors is 2p minus 5, your other one should be p squared minus 2. Okay. I'm going to go to the next one. Look at the GCF between these two and these two. So this is important. The GCF between 6x cubed and 8x squared is going to be 2x to the second power. If I divide each of these by 2x squared, I'll have 3x plus 4. When you look at negative 3x minus 4, and again, I'm going to remind you, this sign is what must come down, a negative sign. Does 3 and 4 have a GCF? No. Do they both have an x? No. But you have to bring something down. So what's a basic number that we can bring down that they really both can go into? 1. So if I divide both of these by negative 1, I'll have positive 3x and positive 4. And I know I'm right because they match. So one term is 2x squared minus 1, and my other one is 3x plus 4. Okay, I'll do one more, and then I will post you guys the answer key. Your GCF of these two is going to be 3x to the second power. If I divide these both by 3x to the second power, I have x minus 1. 3x squared divided by 3x squared is 1. The GCF here, remember your sign's got to come down positive, and it would be positive 2. If I divide these both by 2, I get x minus 1, making my two factors x minus 1 and 3x squared plus 2. Okay, hope you got that. There is your factor by grouping lesson. I'm going to finish the other side and post it as your answer key.